Okay, this is a tutorial that comes with this linked Google Sheet, and you would want to use this Google Sheet in order to conduct your own chi-square test for your own data set. And I'm going to show you how to use this Google Sheet and to complete a chi-square test and what those results would mean. Okay, so the first thing you have to understand about a chi-square test is it's different from a Pearson's or Spearman's test. A Pearson's and a Spearman's test would test the level of relationship, or what we might call correlation, between two data sets. So if X increases, does Y increase? So let's say we take 100 students and they all eat different amounts of calories every day. Would the student that ate the most calories a day put on the most weight? So we could measure their weight, we could measure the calories intake a day, and we could see if there was a correlation between calorie intake and the weight of a student. So we would, with that kind of data, we could use a Spearman test or a Pearson test. A chi-square test is where you are testing for difference between your data sets to see if one data set is very different from another data set. And I'll give you a couple of examples in today's tutorial that will highlight how you could set up your spreadsheet. Okay. In this first example, I am looking at a student who has done a bipolar study of two settlements, in this case Dunning and Perth. And in each settlement, they have interviewed people in their views about how they feel about modern housing developments. And what we can see in this study is that 18 people in Dunning expressed a very strong negative relationship, or a very strong negative score, and gave it a -2. 17 people in Dunning responded as a mildly negative all the way to a very positive view. And we can also see the data for Perth. So for Perth, 5 people interviewed expressed a very strong negative view towards modern housing developments, and 30 either expressed only a mild view, negative view, or a positive view. So the first thing we need to do when conducting a chi-square is you must formulate what we call the null hypothesis. Okay? So the null hypothesis would be, and it would always start as follows: there is no significant difference between the views of people in Dunning and Perth. Towards modern housing developments. Now, it doesn't really matter what your geography study is. The key part of this sentence is the first part, which said there is no significant difference. Okay? You could be looking at there is no significant difference between the soil moisture on a north-facing and a south-facing slope. There is no significant difference between the acidity of a soil in a coniferous forest and a deciduous forest. So the study doesn't matter. I could change these words. Dunning could become a coniferous forest. Perth could become a deciduous forest. I could have 3 categories, and I'll show you in a minute how I could change up that. Okay. Once you've got your null hypothesis, we're going to see whether that null hypothesis stands up to the maths. Okay. Now, we've created these categories to ensure that the minimum number can never be less than 5, which is why actually we've got this strange kind of -2 to +2. There were only 5 -2s in Perth, so we've got none of our categories are less than 5, so we can do the chi-square test. Okay. Now let's show you what the result means. This result is automatically calculated over here. We can see 20.89. Okay. And what that actually means is we have to go over to the critical values table and try to interpret that result. And you can see this D, this actually means degrees of freedom. Now that's another little difference from chi-square and Pearson's. In chi-square and Pearson's, that would be the N. Now, whether the degrees of freedom, I won't explain too much about that, but it's actually to do with the number of columns and rows of data you've got. And we can see we've got 2 columns of data, that's E and F, and we've got 2 rows of data, and that's rows 2 and 3. And there's a little mathematical thing that allows you to calculate the D. In this case, though, it's actually done for you, and it's 1. Okay, so it's the lowest possible degree of freedom you can work with. And therefore, there's 1. Now, what we've got to do is see, is our number, our result of 20.89, bigger than these 3 numbers here? Now, we can see on each occasion it is. Okay? I'll tell you what that means in a second. If our number was bigger than that, we would be able to say our significance level is above that probability. If our number is bigger than that, we could say it's above that probability. And if it's above that, we could say it's above that probability. Now, a 0.05 probability means that you first of all can reject your null hypothesis. The first thing, as soon as you can meet that minimum threshold of the 0.05, then you're rejecting your null. So let's say we had a degrees of freedom of 2. Our number would have to be bigger than this amount. If our degree of freedom was 3, our number would have to be bigger than this amount. Assuming our number is bigger than that, we start by rejecting the null hypothesis. So the first thing I would say is, I can reject my null hypothesis that there is no significant difference between the views of people, and I can accept the alternate. Now, the alternate would be that there is a significant difference between the views of people in Dunning and Perth. The next part of my sentence would be, well, how confident am I? Well, my number is bigger than that, it's bigger than that, and it's actually bigger than that. Let's ignore this last column, okay? We're just gonna, this is actually 99.9% confidence, but generally in geography, we just ignore this high level, and we just deal with 0.01. And because our number is bigger than this, we can say that we can reject it to the 0.01 level. So I would say I can reject my null hypothesis, no significant difference between the views of people in Dunning and Perth towards housing developments, to the 0.01 level, which means I am 99% confident that there is a difference in the views of people in Dunning and Perth. Okay, now let's just change up. Let's just say we are no longer looking at Dunning and Perth. We are looking at a north slope, a west slope, and an east slope on a hillside. And we've got data on soil moisture, and we've got high soil moisture. And let's just say that was soils that had more than 50% of the soil was water. And we've got mid-soil moistures, and that's, let's say, between 25 and 49%. And we've got soils with a low soil moisture, okay? And that's under 25% of the soil is made up of water. And we've tested that by putting them in an oven and baking it off, and there are methods of doing that. And once again, we'd have to have at least 5 samples in order to do this. So I would only be able to create these thresholds if I had 5 samples. And I'll show you what I might do if I didn't in a second. So let's say my north-facing slope has, I had 9 samples that were high in soil moisture. My west, I had 5, and my east, I had 5. On my north slope, I had 8 samples in the mid-range and only 5 on the low. In my west slope, I had 7 and I had 5. And then on my east slope, I had 9 and I had 6. Okay. So first of all, let's just say I only had 3 here. Now, in that case, I wouldn't be able to do the chi-square test. But what I could do is I could change this mid-soil into, instead of high, I could just call this low. And I could put all of my soils that were mid or low into one category. So in this case, I could make that 11. I could make that 13. And this final one is 5 plus 9. I could create that 14. And then I could get rid of these ones because I've put them both together. Okay. And I would change this to low soil moistures, and that would be 0 to 49. I can't imagine a soil without any water in it. And that's how you create your categories. Your categories have always got to have at least 5 samples or 5 counts that meet that criteria. Right, so there's my study. My null hypothesis would have to change. It would be there is no significant difference between the moisture content of a soil and the slopes aspect. Now, the aspect is the direction it faces. So I'm saying it doesn't matter where my soil faces, whether it's north facing, west facing, or east facing, but it would have the same, it would influence the soil moisture. Now, the reason I'm probably testing this is that I'm trying to prove that actually the direction it faces does affect soil moisture. And that would be because certain slopes are colder, like a north-facing slope would be colder. Therefore, there would be less evaporation on a north-facing slope. And because there's less evaporation, there's going to likely be more moisture in the soil. Whereas west and east might have be warmer slopes because they see the sunlight more, and therefore there might be less soil moisture. Let's see whether my theory is correct. Well, first of all, my chi-square result is reported over here. It's 11. This time I've got 2 degrees of freedom, and that's actually because I've got 2 columns, but 3 rows this time. Let's go down to the 2 over here. Is my result bigger, my 11.07 bigger than the required for 2? Well, I can see it's bigger than these 2. It's not reaching this last one of 13.81, but it has got bigger than that. And I did say earlier on that we can ignore this final column. So my result is bigger than that. So what do? I reject this null hypothesis. I would actually say I can reject the null hypothesis and accept the alternate, that there is a significant difference between the moisture content of a soil and the slopes aspect. And I can accept this to the 0.01 significance level, which means that I am 99% confident that this difference exists. Okay, so that's me doing 2 examples. You can substitute what these northwest and east or Dunning and Perth or whatever it is, and these categories as well for whatever it is you're doing in your study, and then get your result calculated for you using the spreadsheet, and then read your result using the degrees of freedom and the result you get using this critical values table. Okay.